Good evening, Sarvana. Send the link, beta. Shall we start the class now, Sarvana? Okay, let's start the class. Sarvana, send the link and say to join fast. Okay, I'll start the class. I don't have time. So we'll start from the beginning, Sarvana. Exactly what is exactly called as vectors. So first we have to understand that in physics already you have studied that what is called as vector and what is called as scalar. From in the physics from the beginning itself, Maheshwar, sorry for late. I was writing a presentation only, so only it got late. I just forgot time itself. Now look here. Now just understand one thing, that when somebody will be talking about physical quantities. So what are physical quantities? The physical quantities like force, work, energy, pressure, temperature, whatever physical quantities in physics are there. Okay, I'm so sorry, Mesh. Today is the only day because I had some special work, so only I got what you called late today. After this, it will not be delayed. Vishika, good evening, Vishika. Now look here. So when we talk about physical quantities, we know that what and all are the physical quantities. Simple way, we know that in physics, you know that what physical quantities are, like force, pressure, acceleration, velocity, which is exactly expressing the unit of physics. Means which is expressing physics is exactly coming as physical quantities like force, time, everything. But each one is specialized into two categories. So there are two categories in which the physical quantities are divided into. One category is called as the scalar one and the other one is exactly called as the vector one. So those physical quantities which can be expressible in the form of direction and magnitude both, they will be called as vector quantities, and the one which can only be expressed as, Manish, good evening, and the one which can only be expressed as what you called only magnitude but no direction, it will be called as scalar quantities. Okay, so vector having both magnitude and direction. So physical quantities are divided into two types. What are the two types in which the physical quantities are divided into? The physical quantities are divided into two types. So scalar and vector. The vector is the one which is having both magnitude and direction. So some examples of it: force is an example, force is an example, acceleration is an example. Okay, now one simple question I am going to ask from you. Let's see what answer you are going to give. Work and energy, are they scalar quantity or vector quantity? Come on, quickly explain. After this we will go to the next section. So I gave some vector quantity examples. I told about good evening Shyam, good evening beta. So I told about, good evening Manisha, I told about vector like force, acceleration. Simple examples I have given. Displacement I talked about, and I told that these all are exactly what? These all are vector because they have magnitude and direction. So force is exactly mass into acceleration. So mass is there but acceleration is direction specific. Because of the presence of acceleration in force, force is a vector quantity. Now acceleration is equal to displacement by what you call velocity by time. So acceleration is velocity by time. So now when acceleration will be velocity, so velocity is a vector quantity. So since velocity is a vector quantity, because of that acceleration dimension is vector. Now velocity is equal to displacement by time. So velocity is exactly dependent on displacement, and displacement is a vector quantity. Because of that, velocity is vector quantity. So from displacement we started, we went to velocity, velocity to acceleration, acceleration to force. Okay, so we just created a link, and in that link, very good, in that link we came to know that ki one quantity vector means others are coming vector, but it is not necessary that always it will be vector. But next important point here, I asked from you that ki work and energy, what are they? See, work and energy, they have magnitude. See, work is exactly the dot product of Fs cos theta. So when we are writing it as Fs cos theta, na, in coming time I am going to teach about it. So now you have to understand that work and energy are scalar quantity. They do have magnitude, but they don't have direction. Okay, so since they have magnitude but they don't have direction, because of that it is exactly called as scalar quantity. So scalar quantity means only magnitude, and vector quantity means magnitude and direction both. So now we are going to go to the next point. It is exactly called as representation of vector. So now what does representation of vector actually means? What does representation of vectors actually means? Okay, Mahesh, answer is absolutely correct, beta. Answer is absolutely correct, Mahesh. It is exactly a scalar quantity. Absolutely correct. So representation of vector. So how can we direct a vector? How can we direct a vector? Okay, can anybody tell me what is the need of presentation of vector? So in mathematics, why we are talking about vectors? What is the need of discussion about vectors? So because there should be a reason behind. Now suddenly we started talking about vectors. There should be a reason behind. So what is the need of vector? What is the need of vector? I just asked this question. What is the need of vector? What is the need of vector? Come on, tell the answer. What is the need of vector? For what you are needing a vector? For what you are needing a vector? A simple question, as simple as it is. For what you are needing a vector? Magnitude to we can directly get. Magnitude too we can directly get. So you will say in simple that, auntie, we don't know more about this because we don't want to do research in this. Only one thing we are knowing that when we talk about vector, right, another mathematical applications, we know that we will be getting some values, we will be getting some variables, we will be getting some solutions. Here also, auntie, we are planning for that, but we are exactly adding an extra point in that, and that is we are going direction specific. We are going direction specific, and since when we want some movement of certain things in a specific direction, then we involve vectors. Because when I am talking about distance, I need not to talk about vector, because distance means I am only going to talk about the magnitude. But when I am talking about displacement, that time I am very much specifically talking about magnitude as well as direction. So for displacement, direction is one of a very important thing. So if somebody will talk to me and say that, today I went 40 kilometers towards east, means he specifically told that his movement, his direction of movement is towards east, and the magnitude or the distance he covered is exactly 40 kilometers. So here we have planned for both. So vector is that one where we can see the movement of the content in a particular direction. That's why in physics also you might have seen that unit charge movement or what you call movement of electron, always we are exactly taking direction accountable into it. And since direction is accountable, so that time it will be coming as a vector quantity. Many a times when we do dot product and cross product, there we have to check that ki overall presentation is coming as vector or scalar. That we are going to check in future, but right now for your understanding, you have to understand that ki where direction is accountable, we are taking overall as it is a vector quantity. Fine, I just want to read Sarvana's point. Vector are needed because some physical quantities has magnitude as well as direction. To represent the physical quantity, we need vector. Absolute, Sarvana. And this is the wholesome point, and that is what I also said, that is, if I want direction specific content in mathematics, that means I need vector. So where I am going to present a physical quantity with respect to direction, then 100% I am going to involve vector in that. Fine. So this was the only need. Many a times they will not ask in mathematics, but definitely it is important, because many a time students are having problem in vector. They feel difficulty in handling vector. So be clear about the concept of vector. You are just adding an additional flavor in mathematics. When you are adding vector, means you are adding an additional flavor in mathematics, and that is direction. Okay, so whichever will be direction specific will come under vector. So now how to present a vector? First thing is that, so now we are going to see that vectors are represented by directed line segment such that the length of the line segment is magnitude. So what is the length of the line segment? The length of the line segment is considered as magnitude. The length of the line segment is magnitude of the vector, and direction of the arrow marked from one end emphasize the direction of the vector. So whenever we will be marking this point, whenever we mark A, B vector, then 100% we are talking about, can you tell me which one is the initial point and which is the terminal point? So A will become the initial point and B will become the terminal point. So what is exactly initial point and terminal point in a vector? The point from where you are starting becomes the initial point, and the direction where you are heading from the initial point will become the terminal point. That is the only concept here. Rest other, no need to waste time. So what did I said? I said that the point from where you are starting will become the initial point, and the point which is exactly telling which direction you are moving will become the terminal point. Okay, so this is the terminal point, this is the initial point. And always when we are writing, so when we are writing like PQ vector, so that means P is the initial point and Q is the terminal point. So that means Q is having the arrow, that means Q is the terminal point. Can you tell me what is the initial point and what is the terminal point here? Come on, quickly type. B will be the final point. Absolutely, Sarna. Can you tell me this one? Come on, quickly say, because I really want your attention today. So now PQ vector, P will become the initial point, Q will become the terminal point, because Q is specifying the movement of the vector. So directly just ZY vector I am just writing. So which is the initial and which is the terminal point. So if somebody will be telling you which one is the initial in Z and which one is the terminal in ZY, then answer will be what? What final answer you are going to give there? What final answer you are going to give there? What final answer? Z is the initial and Y is the terminal. Absolutely. So here Z will become the initial and Y will become the terminal. That's it. We are going to stop that conversation because it need not to be stretched to more limits. Okay. So now sometimes what happens, we can represent a vector AB vector as, sometimes we are representing a vector like AB vector as A vector also. So don't get confused about it. So like AB vector, we can present a vector as AB vector also, and we can write AB vector as A vector also. AB vector as A vector also. AB vector in short as A vector. It is also representing the line segment, magnitude of the line segment. A vector will be exactly representing the magnitude of the line segment. So we are going to talk about magnitude also. So now let's see this one. So that's what we are telling, that vectors are generally represented by A vector, B vector, C vector, and we can also represent vector as AB vector, BC vector, CD vector. So that's the first, today is the first class, so I'm just explaining the all points. Okay, so now we are going to go towards modulus of a vector. So now can you tell me what does modulus of a vector ensures? What does modulus of a vector ensures? Because modulus or module or magnitude of a vector means what? Modulus, module, magnitude of a vector means what? Modulus, module or magnitude of a vector means modulus, module or magnitude of a vector. Modulus, module or magnitude of a vector. And how we can present the modulus, module or magnitude of a vector? Come on, tell me this point. You can be able to tell, I trust. Modulus, module or magnitude of a vector. Magnitude of a vector, yes. So we, in simple way, we can say that when I want values, I will be saying it is modulus. So if I am saying that AB vector, so just one simple thing I am telling you, just listen to my point. Now AB vector AB. A is the point from where the car started and B is the point where the car is exactly going, and they are going towards east and they have covered 15 kilometers. Can you present it in vector? Can you present it in vector? Yes. It is exactly represented by modulus of A vector. Absolutely. So modulus of A vector is the magnitude of a vector. Modulus of A vector. So if somebody will be telling you what is the magnitude of this. So magnitude of this journey. So if I am going to write AB vector magnitude. So what answer I am going to write? I am going towards that only, Maheshwar. Sum of the square root of coefficient is absolutely correct. It will be also called as modulus of a vector or magnitude of a vector or module of a vector. Modulus, magnitude, module of a vector. So here what I am going to write here? Absolutely. So I am just going to write Savna here as 15 kilometer. So here I am not talking about direction, I am just talking about the magnitude. So here the car started its journey from A going towards B. So since the car is starting its journey from A going towards B, covering a distance of 15 kilometer, so magnitude will become what? Magnitude will become pure distance, and that will be equal to 15 kilometer. But if I will say that the car started its journey from A going towards B and covering a distance of 15 kilometer towards east, then directly I just added direction to distance. Direction to distance. The distance covered was 15 kilometer towards east. Since the distance covered was 15 kilometer towards east, it is exactly becoming a vector. Okay, so this is, and it is exactly modulus presentation also we have done, and apart from modulus presentation we have added here one small flavor, and that is the exactly this direction here, and that's why it become a vector. I hope you might have understood this point. Now every vector is exactly having three characteristics. So many a times what happens, we don't need the characteristics of vector, but I want my children to remember about the characteristics of vector. So look here, vector is having a support system. Like when we talk about algebra is incomplete about variables like x, y, z. We talk about coordinates when we talk about, we say about axis. In the same way, when we talk about vector is also having three important characteristics. One is called as length, support, sense. Length, support, sense. The three important pillar of vector is length, support and sense. So what is length? Length in simple you can say magnitude, because we are taking line segment. So you know that line segment is having a specific length or magnitude. So when we talk about a vector will also have exactly a specific magnitude. So because in the definition of vector itself says that the vector has magnitude and direction, it will be exactly vector. Okay, fine. I just repeated vector 2 times. So here you have to understand that what is the length? Length is exactly nothing but the modulus. Length is nothing but the modulus. Length is nothing but what? Modulus. The length of PQ vector is what? PQ vector modulus. So this is exactly presentation of modulus. Okay. Thank you. Thank you, CB. Nice. Now next one. Thank you, CB. You just changed my mood. Support. Now what is exactly called as support? Now you know that another important point you know very nicely about vector, that now if I am going to talk about sun rays, then you will be saying, auntie, why you are talking about sun rays? When we talk about sun rays, now exactly it is a ray. Ray means the exactly light which is moving in a straight line. So here also you have to understand that what is a support. A support is an endless line. A support is an endless line. Okay, and in that support only we are exactly, it is a line. Support is a line, and in the support only we are exactly getting a vector. So that is exactly one of the characteristics. So when we talk about localization and free vectors now, then this support plays a very vital role. Okay, because support gives the point of what you call point of convergence or divergence. Means I'll be explaining it when light chapter we are teaching, that time we talk about. So here you have to understand one thing, that when a line, an endless line is there, and from that inlet line we can expect a vector. So that means that inlet line is exactly acting as a support. So here this line is acting as a support for PQ vector. Okay, so I'm just reading this out. The line of unlimited length of which PQ is a segment. The line of unlimited length, okay, of which PQ is a segment, because a segment have magnitude, a segment have magnitude. So that's what the line of unlimited length of which PQ is a segment is called support of vector. It is exactly called as what? It is exactly called as support of vector. Now we are going to talk about sense. So when we first is exactly magnitude, second is about the one from where the vector is exactly coming, that is the support, and the third is sense. Sense is exactly nothing but direction. Okay, so these are the three important. So magnitude, support and direction. So if I am going to talk about, and they have exactly told it in different name, what are the name they have given? Length, support, sense. What they have talked about it? They talked about it as length, support and sense. So now sense means what? If I am going to talk about PQ vector, so what is the sense of PQ vector? Can anybody tell me? If I have exactly characterized, Mahesh, why you are laughing, right? So if I have characterized PQ vector as, PQ vector. So if I am telling that PQ vector is the form of P to Q and that of QP is from Q to P. So that means what I did, what exactly I am talking about? Mahesh, what exactly I am talking about? Vijay t-shirt, huh? Apart from that, CB, you meet me. Mokka student. One student disturbing the whole class, CB, huh? Come and meet me. Now look here. So that is sense is sense is PQ vector. PQ vector means what, beta? Direction. Sense is giving the direction. Sense is giving what? Sense is exactly giving the direction. So we have seen sense. What exactly we have seen here? We have seen length, support and sense. We have seen what? We have seen length, support and sense. Come on, quickly tell me. Till here everybody understood? Give me assurance that you have understood every point. Then we will go for the next one. We'll go for the next one. Come on, quickly tell me. Come on, tell me fast. Till here all clear? Sense, support and length, the three characteristics of vector. The three characteristics of vector. Now we will go for next one. So next one we are going to start with exactly equality of vector. So when does two vectors will be equal? So till now we have understood about, okay, vector is this, vector is that, modulus is exactly magnitude of a vector, it is also called as module, vector is exactly a physical quantity divided into two types, and then representation of a vector we have understood. Now we are going to go for some specifications. The first is when two vectors are said to be equal. When two vectors are said to be equal. So if I am going to say that two vectors are equal, so when two vectors are said to be equal, when two vectors are said to be equal, when two vectors are said to be equal, then you will say, auntie, why to waste that much time? You know, when two vectors will be equal, so first is, you have studied right now, auntie, characteristics of vector. So if two vectors will match the characteristics, then they will be considered as equal vector. Then they will be considered as equal vector. So first is the direction. So they should have the same direction. So two vectors having the same, what you called, same direction. So what we can see, what word we can use it, sense. Okay, because sense, support and length. We talked about sense, so means direction. When they will have same sense, absolutely correct. So magnitude has to be equal. So A vector will be equal to B vector when they have equal magnitude and and the same direction. So now look here. So two vectors are said to be equal if they have same length, that is same magnitude, and they have same or parallel support or same sense. Sense means direction. So if they will have same sense means direction, and they have same length means magnitude, same length means magnitude, same direction, and they have same or parallel support. Here only one catch is there. What is the catch here is same or parallel support. So if somebody will be telling you how can it be possible, then you have to just draw one line and you can say that this is one vector, this is one vector, and this is another vector. So here A vector and B vector. So they both will also be called as equal vector. They both will also be called as equal vector. Why? Because they have same they have same parallel support, same or parallel support. So here they have the same support. They have the same support. Here we are talking about parallel support. Here we are talking about parallel support. So here we have seen all the examples of equal vectors. In this, all the examples of equal vectors, just see when can two vectors be equal. First is they have parallel support. I told you what is a support. A support is an endless line. Okay, a support is what, beta? A support is an endless line on which a vector is resting. Okay, on which a vector is a part. On which a vector is a part is exactly a support. So when it will have parallel support, so you see here parallel support is there, in that two vectors are there. Now these two vectors have same direction, same magnitude. These two vectors are having what? These two vectors have same direction, same magnitude. Since these two vectors have same direction, same magnitude, it will be called as what? Equal vectors. Here also A and B vectors are called as equal vectors. A and B vectors are exactly called as what? Here equal vectors, because it has same direction, same magnitude. It is having exactly what? Same direction and same magnitude. Here same support and these two vectors are there. So on same support also, if two vectors will be there on same support, see they both are in the same support, and since being in the same support, they have equal magnitude and same direction, equal magnitude. So this one magnitude is equal to this one, and they have the same direction. So they see the arrows are exactly pointing in same direction. So that also will be called as equal vector. That also will be called as equal vector. Let's see some different type of vectors. First vector I have marked it as like vectors. So you can see the definition already we discussed about it. So now I'm going to just speak about this point as what is exactly like vectors. If somebody will be asking you what is like vectors, then what answer you are going to give? Because equal vectors, we understood that either the support will be same or support will be parallel. The two vectors drawn will have equal length and equal sense. Equal length means equal magnitude. Equal sense means, beta, equal sense means same direction. Equal sense means same direction. So come on, tell me the answer, beta. What is exactly called as like vector? What is a like vector first? What is a like vector? How a like vector is different from an equal vector? How a like vector is different from a equal vector? Like vector direction is same, very good. But if somebody will be asking you, Sarvana, how to differentiate a like vector from an equal vector, beta, then what answer you are going to say? How can you differentiate like vector from equal vector? How can you differentiate like vector from equal vector? See, for like vector and equal vector, they can have same support and parallel support. Like vector and equal vector, they will have same support or parallel support. Their direction will be same. But one thing will be different in that. One thing will be different in that. Can you tell me what is that one thing which will be different in that? What will be that one thing? Same direction is absolutely correct. You both are correct. But one thing will be different in that. What is that one thing which is different in that? Absolutely correct, Mesh. Now the statement is absolutely covered up. So they have same direction, but they have different length. Okay, so they have same direction, but they have different length. This is a very important point to note down, sir. Okay, magnitude is different. Absolutely correct, Sarna. So here you have to understand this thing, that when we talk about a vector, and that too about like vector, then we understand that, okay, how to differentiate a like vector from an equal vector. Then you say like vector means they are like, but they are not equal. And how to say that they are not equal? Because their magnitude are different. Their magnitudes are different. Since their magnitudes are different, that's why they cannot be called as equal vector. So how to convert an equal vector into a like vector? So equal vector, direction, support, both same, but only length is different or magnitude is different. Length or magnitude will be different, and because of that they will be considered as like vector. Now other is called as opposite vector. So what is the difference between equal vector or opposite vector? Equal vector or opposite vector, because today itself all that basic zero level work we are going to do. From tomorrow we will start that level work which I am exactly expecting from all of you. Vector is a very simple chapter. It only need proper information, and after that you will pick vector content and throw like this. So what is exactly called as opposite vector? Now what is the difference between opposite vector and equal vector? Opposite vector can be equal vector. Opposite vector can be equal vector. Opposite vector can be equal vector. I just throw one ball towards you. You have to catch it and tell me that really it's caught out and or it's exactly went somewhere. Tell me, opposite vectors can be equal vectors. Opposite vectors can be equal vectors. Am I true or am I joking? They can be from same support. They can be from same support. Catch is there. 100%. A very important point I am going to discuss. So you have to think. Yes, Mahesh. So Mahesh has told that no. Very good, Mahesh. So exactly when basic we are starting, we are talking about opposite vectors. So 100% opposite vectors means supports are parallel. But how can we tell that two vectors are there and they are from line and they will be like this? Is it possible? Or this one is possible more? Which one is more possible? See, opposite vectors cannot be equal vector. Absolutely correct, Sarvana. Opposite vector is having one big problem. They can have same magnitude. They can have same magnitude, parallel support, two things. Same magnitude, parallel support, but different direction. Same magnitude, parallel support, but different direction. This is exactly the most important point. Same magnitude can have, they can not have same magnitude. So opposite vectors means when we are talking about the vectors which is exactly having like this and like this. So means direction 100%, you see my fingers, they are exactly opposite to each other. So 100%, Mahesh, what is happening? Is it buffering for you also? For me it is not buffering. From here it is streaming perfectly, beta. From here it is streaming perfectly. One more time check. So what we talked about opposite vector, can you tell me what we talked about opposite vector? About, it is not buffering now. So about opposite vector, we understood a very important point, that two vectors having parallel support. Two vectors having parallel support can have equal magnitude, not equal magnitude, but their direction will 100% be opposite. So if direction will be, look here, if they will not have same magnitude, then they will be called as unlike vectors. And if they will have same magnitude, it will be called as opposite vector. This is a very important point. This is a very important thing. And one time itself I tried to cover two different things. So now look here, two different things, because after opposite vector you are going to see unlike vector. You are seeing that unlike vectors are those vectors where you can see that direction and magnitude both are different. Direction and magnitude both are different. So since the direction and magnitude both are different and they are belonging to parallel support, so definitely they will be called as unlike vectors. They will be called as unlike vectors. What they are exactly called as? Unlike vectors. Now we are going to, already we have seen equal vectors. After equal vectors, now we are going to talk about co-initial vectors. So what are co-initial vectors? Co-initial vectors till here everybody understood what is the specific difference between equal vectors, like vectors, unlike vectors, opposite vectors. Come on, this 4 type vectors, did you understood? Did you understood what are exactly this 4 type vectors means for? What are these 4 types vector means for? Did you understood this point? Very less this. Very less this. We will finish vectors like anything, because vectors one, but I will discuss the deleted portion also, because that deleted portion will be coming in competition. So 100% that point also I am going to discuss. We will not be able, Ashitosh, good evening. So we will not be leaving anything. We are going to cover up everything. Huh? So now we are going to talk about types of vectors. Types of vector already we understood. So co-initial, now we have finished about like vectors, we talked about unlike vectors, we talked about opposite vectors. Now we are going to talk about co-initial vectors. Equal vectors also we discussed about. Now what is exactly co-initial vectors? Good evening Ashutosh. What is exactly co-initial vector? If somebody will be asking you what is exactly the meaning of co-initial vector, then what you are going to say? So co-initial vector is exactly when two vectors are having the same initial point. So same initiation, same initial point, then that two vectors are exactly called as co-initial vectors, because they have same initial point from where the vectors are emerging. So 100% they will be called as co-initial vectors. I hope you might have understood. Thank you Ashutosh. So I hope you might have understood. So now we are going to talk about the next one called as co-terminal vector. So if somebody will be talking about co-terminal vector, so what is exactly same initial point is called as co-initial vector? Absolutely. Now co-terminal vector or co-terminus vector. Co-terminus vector. If somebody will be asking you about co-terminus vector, then arrows will be exactly going to be like this. So coterminous vector. So if somebody will be asking you about coterminous vector, then what answer you are going to give about coterminous vector? You know that a vector will be having initial point, terminal point. Okay. So what is coterminous vector or terminal vector? Co-terminus vector or terminal vector? Easy or easy busy. So just explain this point. You can say like that, the vectors having the same terminal point, two vectors having the same terminal point, or they are heading towards the same direction and they are exactly meeting at a point, it will be called as coterminus. Okay, so same terminal point or terminus point will be called as coterminus vector or coterminal vector. They are called as coterminus vector or coterminal vector. Now if somebody will be talking about a zero vector or null vector, then what is the meaning of zero vector or null vector? We are just going to say that, because we are just discussing the most good evening Riyaz. Good evening Riyaz. So now look here, types of vectors. If somebody will be talking about zero vector or null vector, what does zero vector or null vector says? Till now we were talking about that a vector will be having an initial point and a terminal point. The vector will be having a specific length, and that length is called as magnitude. A vector will be specified with a direction. So till now we have understood these many things, and suddenly we are heading towards a vector, and that vector is exactly called as, Sarna, still buffering beta for you. So now we are heading towards a vector and directly we are saying that the vector is a null vector. Then how can we convert a vector as a null vector? How can we convert a vector as a null vector? Then you will say that you draw a dot and this is exactly a null vector. So why a dot will be considered as a null vector? Come on, quickly tell me how a dot can be considered as a null vector. How a dot can be considered as a null vector? Then you will say that a dot does not have any direction. A dot does not have any direction, because the moment I will draw one small line and I will just put an arrow, definitely it will be having length and it will be having direction. But when I am going to draw a dot, the dot can have any direction. The dot can move in any one of the direction. So 100% we can say that null vectors are those vectors in which the terminus and the initial points coincides. The terminus and the initial point coincide. So when that type of vectors where initial and terminal point will be same, that type of vectors are called as zero vectors or null vectors. That type of vectors are called as zero vectors or null vectors. We don't need to do research in that. Okay, we just have to understand what are the points which is important and which we are going to use in the coming part. So vector other than null vector is called as, if somebody will be asking you a question, vector other than null vector, so definitely I feel that null vector is not having a direction. It is exactly a point where the initial and the terminus point is meeting. So it is not a, what you call, it is not going to be, it can be representing a vector, but it is not having a proper one. So now the vectors other than null vector is called as, a vector other than null vector is called as, a vector other than null vector means, if I am going to remove null vector from the dictionary of vectors, then other vectors will be called as, then you will say that other vectors will be called as proper vectors, because other vectors will have magnitude, they will have direction. So since the other vectors rather than null vectors have magnitude and direction, and they are having that specific what you call way of presentation, so that's why they will always be called as proper vector beta. Yes, absolutely correct, Riyaz. So Riyaz, we are going to say that ki other than zero vector, whichever vectors are there beta, they will be considered as proper vector, because they will have magnitude and direction. Even unit vector will be exactly direction specified, because we are exactly adding unit vector to specify a direction, okay, or to explain a direction. And because of that beta, we will be considerably calling them as that proper vector. So other vectors will always be considered as proper vector rather than null vectors. Okay, so now we are going to go towards the next point. So like unlike vector, already I told come on, what is the difference between like and unlike vector? Then you will be saying, auntie, like and unlike vector is nothing, auntie. The two vectors are there, so they may have same or parallel support, they will have same direction but different magnitude. It will be called as like vector. Okay, but for unlike vector, auntie, take two supports which will be parallel, they have opposite direction and they have opposite different magnitudes, then it will be called as unlike vectors. When the content or the information of vectors will be in your tip, you will be able to rock and roll in vectors like anything. Okay, now another important point is exactly called as collinear or parallel vectors. Always the definition creates the most important problem, because what is exactly the meaning of same support or parallel support? Now I told you na ki support is an endless line. Support, the characteristics of vector itself says that the vector depends on 3 points. What are they? Magnitude, support and direction. Okay, so support is the endless line, and that's why when we talk about coplanar, collinear, that time we are very much talking about the vectors which will be having a support. Okay, the vectors which will be having a support. So in the definition itself, we have added a very important point, and that is the same support or parallel support. So every time you will be seeing this word same support or parallel support. So if you are understanding that the support is an endless line in which the vector is exactly resting, or the vector is a part of, will be exactly the support. So now we are going to talk about this in much details. So collinear or parallel vectors. So when two vectors will be called as collinear vector. So now we are going to talk about a support. Okay, so now this is a support beta. This line is exactly a support. One line, endless line is a support. Okay, now in this endless line, if we are going to draw two vectors, if we are going to draw two vectors, A vector and B vector, then these two vectors will be considered as collinear vector because they are a part of the same support. They are a part of the same support, so they will be exactly called as collinear vector. What they will be called as? Collinear vector. Right now specifically we are talking about the initiation point of the vectors. Okay, now so this is exactly the presentation. So same support, when two vectors will be there, then that will be called as collinear vectors. Another is when two vectors will be exactly coming from the parallel support also, then also it will be called as collinear. So that is the next important point to remember, because same support everybody will be remembering, but when it comes with the parallel support, it may create problem for you. So you have to understand that two vectors are supposed to be called as collinear vector when they are a part of same support or parallel support. I hope you might have understood this point, when they are a part of same support or parallel support. So this ends as it is. Fine, I hope you might have understood this point. Simple things, we are going to create big changes. Okay, so co-initial vector, when they have the same initial point from where the two vectors are exactly going in different directions, they will be called as co-initial vectors. So now what is co-terminal vectors? Co-terminal vectors means let the two vectors kill each other. Just simply joking. So when they have the same terminal point or terminus point, then it will be called as coterminous vector. So see here, the head is exactly going in one simple direction, so it is called as coterminous vector. We will play with vectors. I'm telling you, vector is nothing, it's just a game. Now look here, like other mathematical concepts, vector is also a game. I may go slow, but I will go deep. Now look here, coplanar vector. What is exactly called as coplanar? First, what is a plane? Plane. What is a plane? Can anybody tell me what is a plane? What is exactly a plane? What is exactly a plane? Define a plane to me first. As a mathematician, I feel plane is something different. So I think layer by layer means different Vera level definition I have of plane. So Riyan, an empty space. Absolutely, Riyaz. But beta, when we talk about space, na, the moment we are taking this word space, we go to 3 dimension. Plane is something which have only 2 axes. Yes, space is containing 3 axes. So vector point of view, beta, when we are talking about a plane, so we will be specifically dealing with 2 axes. No, I'm just giving the beginning definition. For a beginner I am talking about. So when we take a page, I feel like when one page is on my hand, this is a plane. For me, this is a plane. My hand is a plane. This screen is a plane. This screen is a plane. Okay, so empty space, vector lying in a plane. Now vector lying in a plane, vector can be laid on a plane in very different ways. Okay, Sarvana, we can draw many vectors in a plane. We have full SS because a plane is full of points. A plane is full of points. If you think about particle, then you will be saying that, auntie, you know that a plane, the paper which I am having on my hand now, it is having infinite number of points in it. And that many points now, I need only 2 points to draw a line segment. And with that 2 points, I can draw a vector. I'm really talking like something. So really you have to understand that when we talk about a plane, so coplanar means what? Coplanar, both of you are back to back correct, but I really want that depth of information. Okay, so when specifically we deal with a page, you fix information in your brain. Now I am having a page and that page is my plane. and from there only if I am going to draw, because after this you are going to study plane, and in that normal means the teachers will only be speaking the word called as normal, tangential, normal, tangent, this line, that line. So what is exactly those lines we are going to understand afterwards. But what we can draw in a plane is infinite number of vectors. So I am talking about infinite vectors because infinite number of points are there in the plane, so I can draw vectors. So they are belonging to plane. So all the vectors which I am drawing, they will be belonging to the plane. They will be belonging to a plane. So if I am part of this room, that means what? I am present in this room, that means I belongs to this room. So if a vector is present on a plane, so it will be exactly belonging to that plane now. So when two vectors will be present in a plane, they will be called as coplanar. Now that vector will be like vector, unlike vector, different vectors, that is a different story that we will check afterwards. But since they are a part of, so in a page if you are drawing like this, so this is your page I have given you, and in this page you draw two vectors like this, then are they not called as coplanar? Are they not called as coplanar? Are they not called as coplanar? Come on, tell me. Are they not called as coplanar? Then you will be saying, auntie, to the point, it is going to be coplanar. Because it is coming as in a plane. Then you will be having some figures where they will be showing the plane, the vector parallel, the vectors parallel to the plane, and they will also be considered as coplanar. How? Right now we were understanding a page is there. In that page I draw many vectors, and I said that since they belong to the plane, so they are coplanar. And then parallel to this, I can draw vectors. They are a part of that plane. How can it be possible? How can it be possible? Can you think about it? Because you know what? When you see a question, you have to generate an idea. And after that, once you have the idea, you will be able to click to the question in any way. Fine. So you should have that idea. You should have that idea. Let's see. Good evening, beta. So now look here. You should have that idea. So let's always, now we are going to talk about a simple concept here. I talked about a page. Now I'm always sticking to the page. And if somebody will be telling you that one page is there, then I'm thinking outside region of that page. Because if my hand is like this, that means if I'm going to go parallel to my hand, this is exactly one region also. This is exactly one region also. This is exactly one region. So if I'm going to extend my hand, it will exactly going to get extended in this part. It is going to get extended in this part. It is going to get extended and it is going to extended in this part. So this is a plane for me. So if this is a plane, if any vector will be exactly here in different directions, it is also a part of the plane, and that's why it is called as coplanar. That's it. No other informations, no extra informations needed, no research. We are not going to do any rocket science in this. We are only going to understand one simple concept, that this is my plane, this is the region exactly parallel to my plane, and if any vector will be here, I will be calling it as coplanar. That's it. Story over. Okay, so now vector parallel to the same plane or lie on the same plane are called as coplanar. Now you understood the definition. If I am going to draw many, because a plane is made with many points, so many points means what? These 2 points which are exactly, because I know the definition of line segment. I am going to one small class and I am coming to the vector class. So small class definition, when I was small, the teacher taught me that what is a line segment. So line segment means when 2 points are there and between the 2 points whatever length is there, it is considered as line segment. So that line segment will give the magnitude of a vector, okay, and the arrows will be giving the direction. So that is exactly a vector for me. So if 2 different vectors in a plane I am going to draw, I'll scribble and make some arrows. They are exactly called as vector, and the nature of the vector we are going to discuss afterwards, but they are belonging to that page. Since they are belonging to that page, they are called as coplanar vector. I hope you might have understood. Yes, belonging to the same plane, the extended region alone. Absolute, beta, absolute. Super. So now we have understood about coplanar vector. So now it is always possible. So one point I have just added, just understand this point. It is always possible to find a plane parallel to 2 random vectors. In any 2 vectors are always coplanar. See, now you think like me one time, try to think like me one time. Like I feel like now कि when one plane is here now, then parallel to this I can also draw one plane. Now if one plane, two planes are like this, then I can draw one plane perpendicular to this, like, okay. Now if this is two plane, then I can draw one more plane perpendicular to like this, and if like this is there, then I can draw one plane perpendicular. So if I'm going to take a book and I'm going to take the pages of the book, then plane parallel to plane, one page below another plane, another page. So that means many pages will be there, and like that perpendicular pages will also be there. So you have to understand that when one plane will be parallel to the another plane, then the vector which is present in this plane and the vector will be present in this plane, they can also become coplanar. Are they? If they are parallel, think about it and then say. Yes, magnitude plus direction is equal to vector. So think about it, because many a times I think like this, that if I am going to merge two plane together, it will become a plane on one sheet. Okay, one page, two different page you take, and take that page on the third page. So when you are sticking two different page on the third page, come on, tell me, are they not in plane, same plane? Are they not in same plane? And if they are in the same plane, then if I am going to draw two arrows in that, they will be belonging to the same plane. So they will also be called as coplanar. Think about it. So it will help you in plane chapter. So I just started talking about plane chapter because we have much to do in plane chapter, and they are directly related to competitions. So once you will start thinking like that, your SS point will increase. Okay, so now what is called as negative of a vector? I will not do anything. I will say that I started from A to B. I covered a distance of 20 kilometer towards B. So AB vector, magnitude of AB vector will be equal to 20 kilometer. Now what happened? I became mental and I started moving in the same direction. So exactly I went toward east. Now I went mental and I started returning back. So now when I started returning back, exactly I returned back more. So this time I am going towards C, and I covered a distance of 35 kilometer. So what is the final resultant? What is the final resultant here? Direction opposite. Absolutely, beta. That will become direction opposite. But what is the final result here? I started from A, went towards B, towards east. I covered a distance of 20 kilometers. Simple, no rocket science. Simple logic here. Apply and say. Absolutely, Riaz. It is going to be minus 15. Why? Because when this displacement, concept of displacement, A to B, B to A, 0. Because initial and terminal point are coinciding. Since initial and terminal points are coinciding, AB vector minus BA vector, it is exactly going to be 0 vector. That's it. And then the remaining one, because you are moving in opposite direction, it will become minus 15 vectors. So this is exactly the small logic here. So a vector which will have opposite direction of the other vector, the same vector which will be in opposite, it will be called as negative of a vector. So that is not a big thing here. We are going to study more bigger things than this. So now reciprocal of a vector. Reciprocal of a vector means a vector will be there. A vector, a vector is there. Now reciprocal of this vector will be represented by this, to the power minus 1. That is exactly called as reciprocal of a vector. Reciprocal of a vector, magnitude will also be reciprocal. Like if somebody will be giving you a vector will be equal to a, its magnitude is a, then the reciprocal of this vector magnitude will become 1 by a. That's it. But my most important point is localized and free vector, because localized and free vector you are studying in physics many a times. So what is exactly called as localized or free vector? So you itself think, when can you get localized? When can you get localized? How can I localize you? How can I localize you? How can I localize you? Tell me. How can I localize you? If I want to say that, hey, I want to localize you. If I am saying that Khushbu aunty itself want to localize herself, so how I am going to localize? This is not that personal localization that I will be talking to my friends, say seniors, this thing, and I am just going to get localized. No, this is not that localization. In vector, there is a specific way of localization. So what is that way of localization in vector? What is the way of localization in vector? Play with this. Play with this and think about it. Localization of a vector. Making equal, you can say about it, Riyash, but the thing here is, now I am telling myself that if I will say that I belongs to Amya channel, I have not localized myself, because Amya channel can be present anywhere in the space. Amya channel can be present anywhere in the space. But if I am going to say that I am belonging to Amya channel and this channel is in Chennai, that means what? I localized myself. I localized myself. Now I am not a free vector. I am a localized. This is the difference. This is the specific difference. So what is exactly a localized and free vector? Now if you will listen to the definition, you itself will catch the point. Here, a vector which is drawn parallel to a given vector through a specified point in space. So I am going to specify the direction, I am going to specify the point. So right now a localized vector is not a free vector, because it is represented by the presence of some other vector. So if I am saying that this is a vector, and another vector, B vector, is parallel to this vector, that means B vector is not a free vector. B vector is a localized vector, because B is parallel to A vector. So B is not an independent vector. B is not an independent vector because B is presented with the help of A vector. So this is the word called as localization. So if I am saying that, if I am giving my half information, that means I am a free vector because I have not localized with respect to something. But if I am going to say that B vector is opposite to A vector, so here, and B vector is this much centimeter away from A vector, that means I have localized it because I have given the specification details of that vector in space. Specified details of that vector in space, the presence of that vector in space. Okay, so I just explained the presence of that vector in space. So if I am going to talk that, okay, Riaz, you belongs to India and your place is this one, that means what? I localized you, I explained about your location. So this is exactly called as a localized vector. But if I am going to say that you are a vector, that means what? You are a vector, you can be present in any part of the space. That is exactly called as a free vector. That is exactly called as a free vector. That will not be called as specialization. Okay. Check this point. A vector whose modulus is unity, that is unit vector definition. That's what I thought. Why? From where it is coming? Vector depends upon only its length and direction and is independent of its position in space. And it is independent, mark this point, it is independent of its position in space. It is not at all considering, means where it is present we are not knowing it, but it is having magnitude and direction. For sure it is having magnitude and direction, but it is not, we don't know the location because we are not able to specify its position with respect to other thing. That's why it is exactly called as what? It is called as free vector. I hope you might have understood free vector. Next class I am going to talk about unit vector. I hope you might have understood this point. So till now I think we talked about the most basic point about vector. Tomorrow I am just going to show my arm and I am going to tell what is triangle law of vector addition, and then tomorrow we are just going to play with some concepts and we are going to understand what you called many different things. We'll keep on understanding simple logics I am going to use for learning vectors. Okay, fine. So that's it for today. I hope you might have enjoyed today's class. Fine everyone. Tomorrow again 8 o'clock I will meet with all of you. Understood, Sarvana? Many things are there in vector, and vector is the most beautiful chapter of mathematics. Beautiful. I feel it is like a dish, tasty dish. Okay, bye. Good night.